You might have been driving across the country and seen water towers that are up on pedestals that look kind of like the one in this picture here. Well, why do some towns have these sorts of towers? But if you look around LA, we don't have anything of the sort. Well, water towers, the purpose of them is to help give high water pressure in flat areas. So let's say you've got this water tank here. Well, this water is going to help give water pressure so that on the second story of this apartment building, you'll be able to take a nice strong shower. The reason this works is because of something about water and gravity and the way they interact. If you've ever looked at a lake, you notice that the water in the lake is all at the same level. And that's because water always wants to be flat. And it rises pretty much to the same level. And this happens on a lake, but it also happens if you have a system of pipes that are interconnected. This is supposed to represent a cup on the left side and a cup on the right side, and they're connected by this little tube right here. And what happens is that if you look at any particular molecule of water here, it's getting pushed by all of the water that's up on top of it. And that water it's pushing down on this poor little water molecule, which then in turn pushes all the other water molecules in the line. And you basically have this interconnected chain of pushing. And the water is going to stop moving once it's balanced, once there's a same amount of push on one side as on the other, such that everything always rises up to the same level. When we return to our picture of the water tower, if we are looking at, say, this water tower being half full, the water is draining out, connecting through the pipes. Each little water molecule is pushing on the adjacent water molecules so that there's this space for water to go up, and it's being pushed up so that it's trying to get back to the same height that it started off at so that everything can be in balance. In real life, it doesn't quite happen like that because our pipes actually have a fair amount of friction in them. And that friction with the water pipe is going to absorb a little bit of the energy. So that means the further the water travels, the lower its energy will be. And you can see that here, that in this distant house, there's been a lot of friction as the water has traveled through all these pipes. And the water does not rise up to the level of the water tower. It rises up to a much lower level. Groundwater in nature works in a really similar way. You've got water in this recharge zone here, where there's drops of water that are falling onto the soil and percolating through the little holes and pore spaces and cracks in the rock and flowing along here. And if there happens to be, say, a well that you drill where you put a pipe in the ground, that water is going to try and flow back up to the height at which it sort of started off, minus a little bit accounting for the fact that there's friction, which is why this pressure surface here has got a slope to it. Let's go ahead and plug that well up here and use this picture to talk about something else important about water. In this picture, you can see that water can either flow along the surface, which you know from rivers and streams and things like that, or it can soak into the ground and keep sinking, keep sinking, keep sinking until it eventually gets to a place where there's a whole lot of other water that's all pooled together, and this is called an aquifer. Aqua standing for water, and an aquifer is a place where water is going to flow underground. And all these little dots around here to help remind you that this is all a bunch of rock or sand or dirt. Even solid rock actually has a whole lot of little spaces in between mineral grains where water can flow, and has a lot of little cracks that water can flow through. And so there's quite a bit of space within there for the water to move through. Let's take a look at a couple of raindrops and to figure out where they go. And this the simple rule that you probably know from your personal experience, that water flows down slope. And slope here, let's take a look at a raindrop falling on the surface that doesn't soak in, it just travels downhill. And it slows down when it gets to the bottom of the hill, and then maybe comes to a rest here at this little lowest point and starts to pool up here. When water soaks in, it doesn't have a surface that it can flow along. So how does it determine which way to go? Well, the answer is it's still going to flow down slope, but the slope that we're going to be looking at is called the water table. And the water table is the boundary between all this saturated, filled with water rock here, and the rock above it that's not saturated. So if a water drop falls down here, it slows down as it soaks slowly through, percolating through, and then it's going to join up with all these other water molecules, and I made it disappear to represent the fact that all this blue area is other water molecules. And which way is it going to travel then after that? It's going to be governed by the height of this water table. So let's go ahead and see if you can figure out, in the next couple slides, a few challenges to figure out which way water will flow when it's underground.